So when I first looked at this problem, I thought this was one of those problems as like a system of equations problem. And you might remember those where you have something that looks like this, oops, I'm not writing yet. So 3y minus 8x, and maybe this is 10x. So when you have something like this, you have two variables and you have a system of equations, then you get these weird things you can solve by substitution or by elimination. And you might remember that from Algebra 1. And so that was my first thought. It's like, oh, this is going to be somewhat complicated. But it's not that complicated. And maybe some people are getting caught up on trying to make this harder than it is. So I have two equations. I'm just going to write them separately. 8x equals 12. Now, if this is the only thing that appeared on the page, that would be a pretty easy thing to solve. And we'll do that in just a second. The other equation is 2y plus 10 equals 22. So let's just solve the one on the left first. All I need to do is divide on the left by 8, because that will cancel this out, and x equals 12 divided by 8. Now this can simplify, and hopefully you see that both of these have a factor of 4, factor of 4. So this can become 3 over 2. And if you forgot how to simplify fractions, then that's something that just hang out and we can get some more practice with that. But anyways, 3/2 is the answer for that one. If I go to the other equation, I'm going to subtract 10 from both sides. Those cancel out. 2y equals 12. Now I can divide by 2. Those cancel out. Y equals 12 divided by 2 is just 6. So it's asking, what is the sum of these two solutions? So what's 6 plus 3/2? 3/2, if you remember, is just the same thing as 1 and 1/2. So if I add 6 plus 1 and 1/2, I get 7 and 1/2. There it is. So 53% of you had that. Very good. And for those of you who didn't, hopefully you realize where you went wrong and you're good to go at this point. So we're going to start. If all we did was construct the regular hexagon, it would not take us very long. So when we have extra time in class, I like to just get some extra math practice in just for basic math skills. And we already did some of this with our bell work today, but it's a good time to just get some more practice with solving equations. Pretty soon we're going to be doing a lot of equation, and it's good to kind of get our brain wrapped around that again. So what I'm going to do is I'm going to give you guys 1 minute on the clock. And then after 1 minute, I'm going to have this answer box down here. And then anyone can put the answer in, but don't put it in until 1 minute has passed, just so everyone can have a chance. So go ahead and get started. All right, and what's tricky about these problems, and just in general that I've seen in my years, is that when you're dealing with integers, like this is an integer, this is an integer. When you're dealing with that, sometimes it can be a little bit tricky when you're adding and subtracting and stuff like that. So of course, what we want to do is get this variable by itself. So I'm going to start by getting rid of this -5. So if it's -5, I'm going to add 5 to both sides. All right, so that part, hopefully everyone's good with. It's the -8 plus 5. So I like to think of this just in general. I'm not going to do this for every problem, but I like to think of this in terms of a number line if I'm trying to explain it to someone. So -8 is down here. Plus 5 would move me to the right. And that would push me up to -3. Now, if it was -5, it would have pushed me to the left, but it's not. So this is positive. So you can kind of think about it in terms of a number line, like am I sliding to the right or to the left? I don't know if that's helpful for you, but that's something you can think about. Anyways, this will be -3. Now I have n divided by 3 equals -3. And when I'm already dividing, I want to do the opposite, which is to multiply by 3. Because these will cancel out. N is going to equal -3 times 3 becomes -9. So we see the answer down there already. A lot of people were getting it, and a lot of people were getting close. So there you go. Next one, I will clear off everyone's writing, so you don't need to worry about that. Next one is right there, and the timer is going. Okay, so let's just run through this one. I'm not going to spend as much time on these now. There's 5 of these total. This is our second one. So since I have 7 over here, I want to subtract that 7. All right, and that will just cancel it out. I'm left with -9. This is one thing that's worth mentioning. This negative does get brought down, so don't forget about that. Then this -11 minus 7 is -18. All right, and now I can divide by -9 on both sides because I want to get the m by itself. Those cancel out. And -18 divided by -9, these negatives kind of cancel out as well. And we just get 2. So there it is. Very good, everybody. As we're looking at this, if you're realizing there's some stuff that you are not very strong with currently, then this might be a note for you to just kind of write stuff down. And then if you just let me know, then we can work just me and you or something like that on some of these kind of math foundations that we'll need in order for you to do well in this class. All right, that's enough of me talking. Let me clear everything and move on to the next one. All right, there it is. The timer is going. So same sort of thing as before. We have -7. So to get rid of that, remember we're kind of doing PEMDAS in reverse. So PEMDAS is how we evaluate an expression. But when we're solving, we almost want to go in reverse order. If we're adding or subtracting something, then we want to take care of that first. So I'm going to add 7 to both sides. And those cancel out. I'm left with m divided by 9 equals -8 plus 7. Again, that's kind of moving right on the number line. So that's going to move me up to -1. If that doesn't make sense, again, kind of put a star by this problem and we can look at it after class. Okay, now, if I'm doing this PEMDAS in reverse, I'm looking for any multiplication or division. I've got division, so I want to do the opposite. The opposite operation is to multiply by 9 on both sides. We cancel out. M equals -1 times 9 is just -9. And that's what everyone wrote down. Very good. All right. And your next problem, I think this is the second to last one. So the timer has started. Okay, so to start this problem off, there's really nothing different. Since we have 3 added, I'm going to subtract 3 away. So -3 leaves me with 9n equals -150 minus 3 is going to be -153. And at this point, I want to divide by 9. If you have a calculator with you, then this is a very straightforward problem. -153 divided by 9 is going to end up being -17. And for most people, that's exactly what, how you should approach it. You've got a calculator, use it. If for some reason you don't have a calculator, I'll just show you a kind of a trick that you can do. So I've got -153 divided by 9, and I don't know what that is. I could, do some harder work to try and figure that out. But one thing I can do is I can realize that -153 is the same as -99 plus -54. So I just split that up into 2 different terms. That's divided by 9. And then that's going to be the same as -99 over 9 plus -54 over 9. And these I can actually do in my head. And hopefully most of you can do this in your head as well. -99 divided by 9 is just going to be -11 plus -54 divided by 9. Hopefully 54 is one of the multiples of 9, and that's -6. So at this point, -11 plus -6, I can combine to make -17. You don't have to do it this way. And if you have a calculator, just do it. I'm just showing you that there are different ways you can kind of reason through this problem. So very good all around. Last one coming up. And oops. Here it is. Sorry. No, went too far. There it is. And the timer has started. Oh. Now it has. But everyone's getting 7 right here, so that's good. Let's just figure out that last little bit. So the first thing, again, we want to start with this -3 on both sides, -3. No problems with that. among all of our answers. So negative 39 minus 3 is negative 42. And I've got negative 6r. So I want to divide by negative 6. And it turns out when we divide this, we are going to get 7. These negatives kind of cancel each other out. It will be a positive 7. So if you got a negative 7, then you can kind of see what you can probably pretty quickly figure out where you went wrong on that. If you see any other mistakes that you made, just kind of try and learn from those. Nothing wrong with making mistakes. So very good on all that. Again, just some basic math equation solving practice and getting you back into the swing of things a bit. But you won't have any of this in your homework tonight, though I probably will throw in some just equation solving as part of your homeworks regularly, because it's always good to have those skills. Now, let's look at our skill for today. This is our geometry lesson at this point, and we're going to construct a regular hexagon. And I'm not just going to run through the construction. In fact, I decided I'm not even going to construct it here on this screen because it's not going to look very good. But when I say we're going to construct a regular hexagon, does anyone know? Let's just even start with this. What is a hexagon? And if you don't want to speak out your answer, you can maybe try and chat something to me if you think you know what a hexagon is.
Isn't it a shape with like 6 sides or 6 points or whatever?
You got it. It is a six-sided shape. Okay, now we have a generic term called a polygon. A polygon is any shape with 3 or more sides. So a triangle is a polygon. A quadrilateral is a polygon. A 5-sided shape, 3, 4, 5. That is, anyone know the name of that? All right. Maybe some of you know, I'm just going to jump ahead. It's a pentagon when it's 5-sided. And we'll see pentagons in this class. So we're looking at a hexagon, and like Connor said, it's 6 sides. So let me go ahead. Now, here's a hexagon. 1, 2, 3, 4, 5, 6. If I counted right, yeah, that's 6 sides. So that's a hexagon, but that is not what comes to mind when I talk about a hexagon. Here's what you guys are thinking about. All right, something that basically looks like that. Because if just in your mind's eye, I'm guessing that a 6-sided shape looks like the one on the right, not the one on the left. Okay, now this is the one that we call the regular hexagon. And what makes a regular hexagon regular? Well, notice on this one, now I know I didn't draw this perfectly, but roughly, and in a regular hexagon, it would be exactly true. All these sides are the same length. So 6 same length sides, and all these angles on the inside should be the same as well. Again, imagine this one's perfect. I know it's not. So a regular polygon is any polygon. So I'll just write this down at the bottom. If you want to take notes on this, you can, but we're going to come back to regular polygons later. So that's polygon. A regular polygon has all sides are congruent, and I'm going to put this symbol for congruent. That means basically it means equal. All sides are congruent, all angles are congruent. And notice I used this symbol for angles. That's the shorthand that you're allowed to use. So all sides are congruent, all angles are congruent. So let me ask you, what would you call a regular triangle? That one has a special name. And I can give you another hint. You constructed one of these yesterday.
Is it the equilateral triangle?
There you go. Very good. So this is a special case where the equilateral triangle is a regular triangle. So you could call it either one, but we have a special name for it. We call it equilateral. What is the special name we have for a regular quadrilateral?
Square?
That's it. Very good. So all sides are congruent. All angles are 90 degrees in this. So all the angles are congruent. That is a square. So with the triangles and quadrilaterals, we have a special name for it. But everything else we could just call a regular pentagon, a regular hexagon, a regular octagon, and so on. So I'm not going to construct it right here. I just wanted to make sure you know what a regular polygon is. And this is what we're going to be constructing using just a compass and stretch. So that's kind of neat. So I'm going to clear this, and I'm actually going to go over to Delta Math. Oh, before we do that, I would love for you guys to raise your hand and show me that you're here. Zoom this. So in this, we are going to be, now notice what, as part of your lesson, is called constructing a regular hexagon inscribed in a circle. And when we say inscribed, that means all 6 points of our hexagon are going to appear on the circumference of this circle. All right, we don't need to worry about that too much, but I will show you how to construct this. It's actually not that bad, especially after what you did yesterday. You already have an idea. So what I'm going to do is I'm going to start a circle, and I'm going to start it anywhere on the circumference. It doesn't matter where this is. So I could start it right here if I wanted to. I just like to start it at the bottom. Okay, and remember, this does not actually make the circle until I draw it. So now I've done this, and look, it gave me 2 other points. Now, if this is what we did yesterday, we could connect those together, and we could have an equilateral triangle. But we're not concerned with that. I want to move this compass, and notice whenever I do this, it takes the whole compass. I already showed you that the other day, but still. Now, from here, I want to create another circle. And this is one of my favorite constructions. You're going to see in the end, it just looks really pretty. So now, when I did that, I created another intersection point up here. I already have this one, or actually it created that one also. But I'm going to move up to the next one. I'm just going to keep going around the circle this way. So now I'm going to draw a circle here. And notice it keeps running into that middle because the radius never changes. So every single time it's going to go through point J. But now it created a new point for me to go to. And I'm going to move up to that one. Draw a circle. And the cycle repeats. I'm just going to keep going. You can see what's happening here. So I have all these beautiful circles intersecting, and I get to this one right here. And I don't technically need to draw this circle, but we can see it looks so much prettier if we do. All right, now this is not complete. This is not a hexagon, but we do have this beautiful pattern of all these intersecting circles. Notice there are 6 points on the circumference of our circle. So if I just take a segment and I connect all those together, what we find is that all of these are the same distance around the circle. And so I end up with a hexagon that has 6 sides, obviously, with all the sides the same length, and all these angles will end up being the same angle as well. And isn't that just beautiful? So I submit that, and I got a green check mark. All good. So I'll just run through that one more time. And if there are any questions on anything else that we've done in class, you can stick around. But I'll just do this a little bit fast. So I'm just going to start my circle here. I guess I'll just do it here, so it doesn't matter where we start it. All right. So I draw a circle. I get 2 intersection points. This time I'm going to go around clockwise. And I just keep moving to the next intersection point that I create. And you can see there's not much to this construction, especially when the computer can do it really quickly for you. It takes a little bit longer if you're doing it by hand, but of course we're not doing it by hand. And like I said, the last one, I don't need this circle, but I just really like having it because now we have the pretty pattern, connect it all together, and we've got a regular hexagon. That's all there is to it. And the purpose of these constructions is just to show you what's possible, a little bit of what's possible with just a compass and a straight edge. Now, in years past, we would probably do a lot more constructions, but that's all we're going to limit it to for this online geometry. So I want you guys to practice with that tonight. If you have any questions, you can hang out and ask those. If you are feeling good with everything we've covered today, you can have a wonderful day, and I will see you on Monday.